All right, so at this point, I just want to do a couple of quick examples of this. I know you saw this on Kognity or should have already. Okay, make sure that you are keeping up with that.
Quick question, Mr. Jackson.
So we have the rules here. We have the natural exponential function, and then, what was I doing here? The natural log function, which is not e to the x, that's ln of x. Okay? But the basic rule is, it's a nice easy one, if the function is e to the x, the derivative is e to the x.
So it's the same.
It's the same thing. Okay? The derivative of natural log of x, however, is 1 over x. Okay? Now, as we see with the trig functions, where this gets a little bit complicated is not in the law itself. I mean, that's just memorization. It's in using it with the chain rule, and as we'll see in the future, using it within the product rule and the quotient rule. Okay? So, as you can see, right here, we have an example of a composite function, a composite exponential function. Anytime you're taking the derivative of a composite function, you have to use what?
dy du
The chain rule.
the chain rule.
The chain rule, dy du times du dx, okay? So right here, this is the chain rule. Notice here, the e to the power stays the same, okay? But then you multiply by the derivative of whatever that power is. So it's e to the f of x times the derivative of f of x, okay? The natural log, we see the same thing. Here we have, again, the chain rule. And if I'm doing the derivative of ln of f of x, it's going to be 1 over f of x times the derivative of f of x. And you can simplify that to just be f prime of x over f of x. Okay? One common mistake people make is they'll put that derivative in the denominator too. That's not how it works. Okay? You're multiplying the whole thing by the derivative of that inner function. Okay? Now, I wanted to do a quick example here of kind of a more complicated one that we actually cannot do at this point any other way. And that is natural log of radical x times sine of x. Okay? And we can't do it any other way at this point because we don't know a product rule yet. We don't know how to find the derivative of those two things multiplied together. Okay? Because as you are doing the derivative, you might say, okay, well, dy dx, this is going to be 1 over radical x times sine of x times the derivative of radical x times sine of x. And this is what we don't know how to do yet. Okay? However, notice here I say the properties of logarithms can actually make differentiation easier. And what we're going to do here is we're going to rewrite y in a way that we can take the derivative. And actually, even if we did know the product rule, it might even be easier to do this anyways. Okay? So I'm going to rewrite y as, you'll notice here, I have natural log of a product equals the natural log of one factor plus the natural log of the other factor. And remember, the reason for that is because when you multiply things, you add the exponents. All right? And remember, logarithms are just exponents. All right? So here we have natural log of x to the 1/2, or the radical x, plus natural log of sine of x. Okay? Now I can do the derivative of the sum. Okay, so now I know how to do dy dx. I'm going to first of all take the derivative of ln of x to the 1/2. Okay? Well, the derivative of a natural log is 1 over the x to the 1/2. Then I have to multiply by the derivative of x to the 1/2. What's the derivative of x to the 1/2?
1 over x is 1 over 1/2 x. 1 over negative x to the negative 1/2.
Yeah, okay. And that does simplify to negative 1 over 2 root x. Okay?
Oh, wait. Hold on.
So notice here, that's all just the derivative of this first part. Okay?
So, wait.
That's terrible, I can't even see it. I can barely see it. Can you see it?
I'm kind of
Yeah,
Yeah.
confused, actually.
you're fine.
Okay? So I just took the derivative of the first half. For a natural log, it's 1 over whatever you're taking the natural log of, the argument. It's 1 over the argument times the derivative of that argument. Okay? So 1 over x to the 1/2 times the derivative of x to the 1/2. Okay? Let's do it again with the second one. I think it might make
I'm
sense.
still kind of confused, but okay.
Okay, I think if we do the second one, it'll help. So now I'm going to do the derivative. I'm going to do the derivative of ln of sine of x. Okay. So if I'm doing the derivative of ln of sine of x, the first thing I need to do is I'm going to put 1 over sine of x. 1 over the argument. Then I need to multiply that by the derivative of the argument. What's the derivative of sine?
Oh.
It-
Negative cosine.
It's cosine. Okay? So again, 1 over the argument times the derivative of the argument. Okay?
So wait, you're just taking
So 1 over.
the log derivative, and then the derivative of the actual argument?
Yes. Yeah, because we're using the chain rule here. Sine is a function inside the logarithm function. Okay? And then we can just simplify from there. This is 1 over 2x to the 1/2 times x to the 1/2 plus cosine x over sine x.
Isn't that cotangent?
That is cotangent. And x to the 1/2 times x to the 1/2 is just x. So this is 1 over 2x.
So 1/2 x plus cotangent x. That's it.
Yeah, 1 over 2x, not 1/2 x.
Oh, yeah.
But 1 over 2x. Yeah, you should simplify that stuff. Okay?
Okay.
Does that make okay sense? We'll do one other, a little bit more simple example of a logarithm here in a sec. Just so you can see it done again. Okay?
Wait, why would it be, isn't one of the 1/2s a negative?
It was, but then I brought it down to the denominator, so now it's positive. Alright, so now let's do one example of an exponential, and then we'll do one more example of the logarithm, and then I'll let you guys work on some of these in groups, okay? So here's what we're doing. Pick one. H. Okay, so let's do H. So I have e to the x plus e to the negative x all over 2. That's y. Now the first thing I'm going to do, and I don't necessarily have to write it this way, but just at least in my head I'm thinking this way. That over 2 part is really just a constant multiple, right? So I could rewrite this as 1/2 times e to the x plus e to the negative x. And the reason why I'm saying think about it this way is because with a constant multiple, you can just find the derivative of the other part and just at the end multiply by a half. Okay, so as we're doing the derivative, we don't need to worry about that half until the very end. Okay.
Why is it covering like both EX?
Well, it's under both of them. So I factored it out, and if I distributed it in, it would go to both of them.
Okay. Oh, so they're both still on top. Okay.
Yeah, they're both still on top. Okay. All right, so now what I want to do is I'm going to have that 1/2 there still. But now I just need to take the derivative of, it's in the parentheses. So what's the derivative of e to the x?
Yeah, e to the x.
E to the x.
But don't you have to do, to find the derivative of, or whatever, the time we had to do in the last one? Oh, this is a different thing. Never mind.
Yeah, this is the exponential function. The last was the
Gotcha. So you have to do the 1 over
log function. Yeah, that's the log function.
Gotcha.
Okay? So now we have e to the negative x. And this one we are going to need to use the chain rule for. So watch how this works, okay? For this part, okay, u, the inner function is what?
E to the x plus e to the negative x? Or you're talking about just that one?
Just for this little part at the end.
E.
No?
Negative e. 1? No, I'm kidding.
What's the inside function?
E. Natural, no.
I know.
I don't know.
Yeah.
Natural law.
E to the u is the outer function. E to a power.
Right. Wait.
So what's u?
X? That's the x.
Negative x. If it were just x, then that's the same. That's what the first one is. So it's just e to the x. Here, though, we don't just have a plain old x here. We got to think about the chain rule. Okay.
How would that be inner?
Yeah.
Because the negative x is inside the exponent of e.
So why are we doing this for e of x?
Well, you could, but what's the derivative of x?
1.
1. So multiplying by 1 doesn't change anything.
One.
Okay? So, I mean, you can, but... Alright, so here, first of all, the derivative of e to the negative x is going to be e to the negative x, but then I got to multiply by
Negative 1.
-1, which is my u prime, yeah, okay? So it's -1 times e to the negative x, okay?
So you could just do negative e to the negative x, right?
So it's e to the x, yeah, minus e to the negative x. And I can put this whole thing back over too.
That's it?
That's it.
Why does this one seem so much easier?
Well, the exponentials tend to be a little bit easier than the logarithms.
Gotcha.
So why can't you just rewrite the logarithms as exponentials?
Uh,
Or does that not
well, you
always
can't
work
just
out to
do
be
that.
simple
I mean,
as this? I'm really
so, yes,
I'm very sorry. The -1.
yes.
How did you get that again?
The -1 came from here. Du dx is, what's the derivative of negative x?
The ones, so 1 negative, oh, get it.
That's the -1.
Okay.
Okay?
Wait, so it says here that if you're doing e to a function, it's e to the f of x times f, or to times the derivative of that. Oh,
Yep.
okay, yeah. So the derivative is going to be -1, and you just times that. Okay.
Yeah. And that's just a different way of writing the chain rule. Instead of u's, they have f of x's there. Okay?
So for the logarithmic one, when we're doing the functions, I was trying to figure out how that could relate to the equation that it gives us, like u over f of x. It doesn't make any sense to me. Logarithm.
Okay, let's check with a different one here. Let's do B. Okay? So, using the notation that's in the rule at the beginning, we have ln of f of x, right?
Pretty much, yeah.
So I know that the derivative of ln of f of x is 1 over f of x
Wait,
times the derivative of f of x. That's the rule exactly how it's stated above. Okay? What is f of x here?
2x.
F of x is 2x plus 1. Okay, I'm using the notation that the rule had up above, just so to try to clarify here. Okay? So, if f of x is 2x plus 1, what is f prime of x?
wouldn't it be 2?
It would be 2. Okay? So, in this case, my derivative is f prime is 2 over the original f of x, 2x plus 1.
When it's like that, then that's easy. But I don't feel like the other one that you showed us, I don't think how that applies to the formula.
Okay.
Let's do another one with the trig just so you can see it, okay? Let's say that I had ln of tangent of x. Okay, that's my y.
Wait, y equals.
Ln of tangent of x. Okay? So, tangent is that inside function, which in our notation for this rule was the f of x.
So f of x equals 2x.
Okay?
Okay.
So what's f prime of x?
Sine over I don't know.
Oh, it's
Derivative of tangent is
squared x.
secant squared. Okay? Secant squared x. So, according to our rule, okay, the derivative of ln of a function is the derivative of that function over the original function, f prime of x over f of x. Okay? So in this case, that would be secant squared over tangent.
Well, when it's like that, it's easy. But the other one, we did like 5 other steps. Like we did the 1 over x, and then times the derivative.
Well, that's because in the original problem back there, we had more than one thing inside the natural log. Okay? We had like a natural log. We could do the same thing here. If we had x squared plus, not plus, that wouldn't work, times tangent of x,
Yeah, can we do this? Actually?
okay, all I would have done is rewrite it as ln of x squared plus ln of tangent of x.
So you find the derivative of both f of x's?
Yeah, so this would be
2x.
1 over x squared times 2x.
Wait. Oh.
A natural log is 1 over the argument, so 1 over x squared,
When you put it
times
like that,
the
it makes
derivative.
sense. When you put it
Okay.
like that, it makes way more sense.
And then it would be plus what we just got down here, the secant squared over tangent.
That's actually much easier to
Okay.
do.
And by the way, the secant squared over tangent can simplify. Alright?
For what?
Secant squared is 1 over cosine squared. So actually I can put the cosine squared down here. And tangent is sine over cosine, but since it's in the denominator, I can flip it and make that cosine over sine.
I actually get it now.
So one of the cosines cancels and I have 1 over cosine x sine x. Some of this is just, we're a little bit rusty on our trig, okay?
This actually makes sense.
Okay?
Well, yeah, I get it now.
So, and actually I should have, okay. Okay. I know it takes some practice, but that's why we're doing so much practice here. That's why we go over so many, why I give you a good amount of practice to do in class and do with your partners, because you can help each other kind of figure out all the mechanics of this, alright? So that's what we're going to do the remainder of our time here. I'm going to give you time here to practice and, again, work together, help each other, and you guys can figure it out.